Welcome back to algebra practice. This question asks us, which one is a linear function? Which one is a quadratic? Which one is exponential function? Let us look at quadratic. Quadratic means your degree is 2. We see here, degree is 2. And we also have learned, remember, quadratic function has ax squared plus bx plus c form. This is a quadratic standard form. Now, we say this is a. Exponential. Exponential has a form y equals a times b to the x power. You see choice 2. A, b, x power. So this is C. Linear. This is in the form of y equals mx plus b form. Now we reviewed linear, quadratic, exponential. Let us look at our next practice. This time we got 3 tables. It asks us which one is linear. The first one, second one, third one. Which one is quadratic? Which one is exponential? Remember, in order to be linear, we need to check. Let us start all over. 3, 2, 1. This time, we got 3 tables. And the question is the same. Ask us which one is linear, which one is quadratic, which one is exponential. Now, job number 1, we need to check if the increments between the successive x values are equal. So check 1. Increments here from -1 to 0, add 1. 0 to 1, add 1. 1 to 2, add 1. So the increments between successive x values are equal. Let's check this again. Is the increments between successive x values are equal? That's right, add 1. How about here? Increments between successive x values, are they equal? Yes, equal. Add 1. Now, in order to be linear, we need to check if the successive value, successive y values, do they have the equal difference? Which means I'm going to look at 5 minus 2. That is 3, so I add 3. 8 minus 5. That's 3, so add 3. 11 minus 8, 3. We notice that the differences of successive y values are all equal. That means table 1 is linear. Table 2. We already checked the increments between successive x values are equal. Now we want to check ratio. If the ratios of successive y values are all equal, 0.5 divided by 0.25, we have 2. 1 divided by 0.5, we have 2. 2 divided by 1, we have 2. We indeed got the ratio of successive y values are all equal. Therefore, table 2 is exponential. Let us look at table 3. For table 3, we already checked the increments between successive x values are equal. Now, we want to check the first difference. 2 minus 5. 2 minus 5. Let's use the same color. 2 minus 5 gives us -3. 1 minus 2, negative 1. 2 minus 1, positive 1. 5 minus 2, positive 3. We don't say same, difference. How about we divide it? We get a ratio. 2 divided by 5. Let's just keep it. 2 over 5. And 1 divided by 2. 1 over 2. 2 divided by 1, that is 2. And 5 divided by 2, 5 over 2. We also don't get the same ratio. What should we do? Let us be patient with it. We erased the ratio part because once the ratio is not the same, we don't have to consider exponential anymore. We got the first time we subtracted, so this is called first difference. Let us try again. What if we subtract it again? We're going to use negative 1 minus 3. We have 2. We're going to use 1 minus 1. We have 2. We're going to use 3 minus 1. We have 2. Although we did not get first difference the same, when we subtract the first difference, the successive value of first difference, we get the same second difference. So we're going to write down second difference is the same. This is quadratic because the rule says if the increments between successive x values equal, the differences of successive first differences of y values are all equal, that is quadratic. In plain language, we say you're gonna subtract the first time. You subtract it, you don't have the same difference. Don't worry, you're gonna subtract again. Successive first difference. Subtract again. You got same second difference. Now, this is quadratic. We're going to write down. This is quadratic. Okay, that's how you find out the different types of functions. Function is beautiful relation. Happy learning.